Number 4. How many liters of hydrogen will be produced at 280.0 K? Oh, hey, look. They're giving us a temperature, and it's not in degrees Celsius. It's already in Kelvin. That's cool. And 96.0 kPa. Oh, well, that's where they're getting us, right? We're not going to be able to use our normal R value if we have our pressure in terms of kPa. We want it to be in terms of atmospheres. So let's convert this number of kPa into atmospheres so that we can plug our normal value for R into our equation. This ends up being 0.947 atm. Okay, so we'll use this value for pressure so that I can still use my 0.0821 value for R. If 1.74 moles of sodium react with excess water, according to this equation. So we have this many moles of sodium. Now you might be thinking, let's throw all of these numbers into the ideal gas law, right? Solve for a volume of sodium and use volume to volume ratios to convert from sodium to hydrogen. Now, that's a great idea. It's a fantastic idea, right? Use the ideal gas law, get a volume, then use volume to volume ratios because temperature and pressure aren't changing. That's a great idea. However, notice that bad boy is a solid. It's a solid. And so we can't use a volume to volume ratio because we can only use that for gases. But what we can do is use mole to mole ratios. Thank goodness. So we'll take this 1.47 moles of sodium and convert from moles of sodium into moles of H2. And we see that moles of sodium will cancel and I'll end up with moles of H2. This is a 1 to 2 ratio. 1.74 divided by 2 equals 0.87. I need 3 sig figs. So I'm going to use this as my value for N, not that, because I want to be talking about hydrogen. So now I'm talking about hydrogen. This is the moles of hydrogen. So solving for volume, I'm going to use volume is equal to N R T divided by P. Now I get to use my normal value for R because I'm going to put in my atmospheres for pressure. So I just figured out this is 0.870 moles. R is my normal R value because I did that conversion. Puts me an L. And my pressure. Oh, right, atmospheres cancel with atmospheres. That's why I needed to put my pressure into atmospheres and not kPa, so that I could cancel right there. Moles cancel with moles, kelvins cancel with kelvins. The only unit I have left is liters right there. And let's see what numbers we got. Let's do a calculation here. So times 0.0821 times 280 all divided by 0.947 to 3 sig figs, 21.1 liters of hydrogen.